And okay, you can record. That's fine. This is a fun one. Please, at any point in time, especially being, a online users group where it's not like I'm doing this at a conference and there's a hard cutoff time. Stop, ask questions. I don't want to go way over, but it's not like I'm trying to hit a firm time limit here. So please, ask everything you want. This is Introduction to Game Design. It is, after many years of giving this talk, this talk started way back in the day on an Xbox 360 with how to use X and A to write games to an Xbox. And over technology changes and years, this has more devolved into what it is now, which is just hey, here are the things you need to know to write games. So after this, you should at least know the terminology and the tools and the tricks and the way things are laid out in what most modern games are. But one of the things that's really important to remember is that with this stuff, there are no rules. I will give you kind of best practices and the way people start to try to do things. But for certain aspects, sometimes there are better ways to do it. And any dev will tell you, hey, yeah, this is what should happen. But to get this to happen, we had to do this crazy thing over here. So these are all just guidelines. Keep that in mind. It's to get you started in the right direction. As far as the obligatory narcissist slide, as was mentioned, my name is Chris Gardner. I'm the chairman of the Dev Space Technical Conference, which is a 2-day conference down here in Huntsville, Alabama, typically in early September. We are still working with our venue to get our dates for this year, so I don't want to say exactly when it is, but it's beginning of September normally. I'm also a senior products and services manager at Accenture. I work in the PPES group, which is the product and platform engineering services. If you have any questions about that, feel free to get a hold of me. I'm also an MVP in development technologies. Blah. But first, let's talk about where we're going. As far as overall, first we're going to talk about some of the tools you need to think about when it comes to what you can use to build your own games. Then we'll talk about inputs, because sometimes the input itself can actually guide the rest of it. If you know you're using, I think I got one over here. If you know this is going to be your input method, that's much different than if you know that's going to be your input method. They're just different concerns to worry about. After that, we'll talk about some of the design fundamentals, just the way the general architecture, the 30,000 foot view of how games are put together. And then we'll talk about the way you break it up into components, and then the world overall and how you put everything together at the end. And if there's anything I miss or you think, again, stop me at any point in time. So first, let's talk about some of the tools you'll need. I've broken this down into 3 general ways. You're going to run into, first, there are your engine-based ones. Of course, if you really want to get started, and it was made primarily for kids, but if you just want to get the fundamentals of the game loop, which we'll get into later and all that, of course, you can use Scratch. There are these other engine-based ones that you can get that are free and get used quite often. There's Click Team, which is right there, Constructory, Game Maker Studio.
808-250-3220. Thank you.
Okay. So as far as some of these goes, I mean, and you can even get some big name things in there. The reason I added Click Team in there, which is relatively lesser known, is because if I recall correctly, this little game called Five Nights at Freddy's was made in Click Team. Go figure. So you can do some really cool stuff with even these very engine-based cool tools that are very limited and drag and drop. You can still do some great things with them. Of course, if you want to go that next step up with your engine-based games, you can talk about the full-blown engines. The most common one you hear about for indie game development is typically Unity. It is 100% free to get started on. You can then buy modules. I believe the overall Windows module is free and the overall web module is free, but then it's $500 to cross-compile to the Xbox and $500 to cross-compile to the PlayStation and things like that. So it gives you enough to get started with, get everything built, and then put off spending any money until the end. Also, with all of these, but particularly Unity, they have asset stores built in. So if you're not the world's greatest artist, you can go to their asset store and they'll be here are character models, and you just download them and can plop them right into your game. We used to joke that you can find a Unity game from a mile away because they used all the free resources in the Unity asset store. And once you know what they look like, you'll be amazed how often you see them everywhere. On top of that, you've got some other ones like CryEngine. This is the ones that like Far Cry and Crysis, a very big name one. They do have a version you can download and play around with for free, but I don't think you can release anything with CryEngine until you pay them for them. And then Unreal Engine, right now they're up to Unreal Engine 5. Unreal Engine is 100% free right now. They don't ask for money until you make a certain amount of money. And I think it's something like they ask for 15% royalties once you make $100,000 off your game. As far as I'm concerned, if I make $100,000 off my game, you can have that 15,000. Seems like a good compromise to me. But that's the way it works. And I think all of them now you can also get on subscription models, kind of because everybody just wants your $50 a month, right? That's the way it all works. Of course, you can also just do everything from the ground up. The type of development I normally do, like when I'm doing game development on my Twitch streams or on the side or whatnot, I typically use an engine called it used to be XNA, but now it's called Monogame. It is very much you start with a code screen and the only thing they give you is the game loop. And everything else is written by scratch. You can go completely by scratch, do things straight in DirectX with window handles, straight in OpenGL. All of those raw tools are available. And typically speaking, that's what the engines are all using behind the scenes. So it depends on how much control you want. Any questions at this point? Anybody have a favorite game engine they've heard about or used or want to mention? We good so far?
Yep.
All right, and it is worth mentioning, I do have a second screen open. I have the chat open, all of that other good stuff. So feel free, ask questions, all that other, all of that stuff. So where are we next? Let's talk about inputs. So if you talk about inputs, and this is me trying to get people to talk and be interactive. So please be interactive. It makes it more fun for everybody. What are some of the type of inputs you can think about? Hopefully you never have to work with Rob the Robot. I mean, he was fun in the past, but very much a relic. But what are some of the types of inputs you can think about these days? We got 4.
I guess controller and keyboard and mouse are kind of kings, right?
Right. And
right.
From that, I'm going even a little more generic in that. Because if you're talking about a keyboard input, you're almost exclusively talking about a digital input. You're talking about an on or an off. Is the key down? Is the key up? So from there, your touchscreen, controller, joystick, seeing some other stuff in here. These are all good. So let's break it down into 4 general categories. And in my next, do I suggest C# or C++ for game development? I suggest you use the language you're most comfortable with when you're first using. There are good libraries in just about every language. The only language I've ever said don't release a game in is Ruby, because Ruby is super non-performant. But learn on Ruby and then move it to another language. Definitely. So the reason people use things like C++ and assembly when they make AAA games is the raw performance. But there have been plenty of people who have used C# or other languages like that to build high quality release to the public games. So use the language you're more comfortable with. And then if you need more performance, start looking at parts in the other options. All right, back to the idea of the inputs. So in my clickbaity introduction, there are 4 types of inputs. Number 4 will shock you. Really, we're talking about digital inputs, analog inputs, natural inputs, and network inputs. And network is the big one. So that's the one that gets weird. But with all of these ideas, what are some examples of digital inputs, right? We've already mentioned a couple, like the keyboard up and down. We have certain parts of the mouse. Like if you press the scroll wheel, that's a button. If you press the buttons, that's a button. The scroll wheel itself is actually a digital input, because most of them don't register it's moved this much. When you roll a mouse wheel, most of them you'll have a little click. You just got scroll up, scroll up, scroll up, scroll up. You don't get I've moved this much. If you're talking about your controllers, right? The D-pad, it's named that's the side. It's named the D-pad because those are digital inputs. Digital down, digital up, digital left, digital right. The button faces, those are. These top buttons are. The click of the sticks, those are digital inputs. And if you're talking about touchscreen, something like a tap, if you're just registering a tap happened, that's a digital input. It's just when you get that, hey, this event happened. And digital inputs are really good for line of business people who haven't done a lot of game development, because it's the most intuitive to them. It's like, here's an event. This happened, respond to it. This happened, respond to it. You can make plenty of games just using digital inputs. And that's not even going back to the idea of Nintendo did everything on the NES with digital inputs and the D-pad and the buttons on the NES controller. No, I've seen plenty of people who can just use, keyboard and keyboard buttons, never have to touch the mouse. Everything's a digital on or off, and they can respond completely fine to everything going on. So here, I've been dabbling with Rust with the Bevy engine as a way to learn a little bit of Rust. Bevy is a pretty new engine, but one of the more talked about that is Rust native. Rust will compete with C for speed, but fewer opportunities to shoot yourself in the foot. Yeah, because Rust was built to be won't let you shoot yourself in the foot, but very low level. It was kind of meant as the compromise to what C and C++ became.
Yeah, I was replying to someone with the mic with the C# or C++ there, so didn't mean to distract Olkan, but yeah, it's pretty nice to work with, but you got to kind of bend your brain a little bit coming from .NET world and so on when you're working with it.
I mean, I saw something the other day on Mastodon where somebody's doing, it's still .NET per se, but somebody is doing a game open source like on Twitch in F#. So they're writing a game completely in a functional language, which to me just completely breaks my brain when I start thinking about things. But, kind of watching them go through, it's been a little exciting. All right. Analog inputs. You've got your mouse. This is where some scroll wheels do have natural scrolling, so that can do that, but just the mouse movement. It doesn't respond to you. Excuse me. That I went up, I went down. It says, from the last time I was sitting in a position, I moved this much in the X direction and this much in a Y direction. And that's the input you get. With the control sticks on a controller, if it's in the center, you're at 0, and it goes between a Y direction for one being full up, for -1 being full down, and then left and right, and you get that offset of the position of the controller during the sample point. The triggers give you between 0 and 1 based on how far down you put them. For touch, if you're doing like a drag along the screen, you get, I moved this much in this direction from the last sample point. So these are examples of analog. They're like, you're not getting it's on or off. You're getting some sort of gray area of I've moved this much. The best way to think about these really is when you're talking about like the analog sticks, because they really are, here is the position between the extremes, not just the offsets, which get a little weirder to talk about. And if you want to go full weird, and this is, I need to update this slide, but let's talk about natural inputs. This is when you're talking about touch and gestures and things like that. What's the big thing I really need to add to this slide that I haven't done yet? It's kind of in there. Meta world, you're enough in the right direction. Talking about like motions with motion controls, things like famously the Wii, but the Wii kind of cheated in the way it did it. But other things like, PlayStation Move, the VR hand sticks they use for all that. that type of natural motion and capturing those types of things. Also, the Kinect back in the day, completely underrated device. When you're talking about touch gestures, this is when it picks up a swipe. That's a natural input. Leap motion isn't really talked about anymore because it was the way to turn touch screens or non-touch screens into touch screens back in the day. I have one back there somewhere. I'm not going to go dig it out right now. But it was a little box about that big, about that big. You set it under your monitor and it would capture the input of your hands up on the monitor, and you could get natural input that way. So these type of interactions, and all of those are similar to your analog inputs, but generally there's a lot more that goes into it. If you had ever played around with Kinect development back in the day, when you had a person and you were reacting to what they did, you literally just got the position in 3 space of certain joints, and then you had to manually connect the bones between them to see what the entire body was doing. And finally, let's talk about network input. Right, it's used for online gaming. Mostly, it's like the notification of movements of other players. You can send, hey, in my game world, the player's now here. If you're like slinging UDP packets, you could just be like, hey, here's player 2's controls, and just render it all out. Kind of depends on the type of world you're dealing with. But it's really something you have to think about as an input, because this is this thing coming in, and you're not getting it at the split second, 30 frames a second sample rate you're getting of the controllers. You're getting it when the packet comes in, and you have to update and respond to it. So you really do need to think about it as a separate input and how it's coming in. We'll talk a little bit more about this type of stuff a little later when we start talking about the world in general. But just remember, what's coming in off the network is an input. It is actively changing the state of your world. So it is something that has to be contended with from the outside. Any questions, comments, anything? Anybody want to talk about a different type of input I may have missed, where I can tell you it's just really one of the other 4 or anything like that? We good so far? All righty, let's talk about what about voice input? Believe it or not, voice input, we'll come back here real quick. Voice input, the way it's normally done, or at least the way I've done it on the Kinect. I haven't played around with a lot of the modern voice ones. You would say it in the background, it would do the natural language processing for you. It would figure out the word. You would turn the allowed words into a map to a tag, and then it would kick off an event saying this tag was done. So it's almost like a digital input. Otherwise, you're talking about the language processor is just giving you the sentence and you have to parse it yourself. I don't know what category I would put that one in. That may be an example of natural. But like, I know, like with the Kinect, it was like you would say this long sentence, or you would say the trigger word, and it would just fire an event saying this happened. And I used to have an example where I would have some stuff on the screen, and you could say a color, and it would change the color to that. And the classic way I showed that it was an input, or that it was doing a tag, was that I had the screen turn pink when I said pink, but it would also turn pink when I said fuchsia, because you could map 2 words to 1 tag. Typically speaking, that's the way most voice input works, unless you're doing something like, let's say, with speech recognition and ChatGPT, where you're naturally saying something and all it's doing is translating the words using some small amounts of AI plus the recognized words to clean it up, and it drops it into a chat box, which then something else does natural language processing on. But considering the amount of times I'm saying the word natural, we'll throw it under natural. All right. So now we'll talk about the fundamentals of game design. I've mentioned this a couple times, and here we're going to go into the overall general architecture. And this is the general architecture for almost every game, but it's also the general architecture of almost everything on your computer. And it's what we affectionately refer to as the game loop. This is the game loop. This is technically XNA/mono games. game loop. And I like using it not just because that's my tooling of choice, but because it had the simplest one to look at and deal with. The game starts, you go into initialize. That is where you set up everything you need to set up beforehand. Think about everything in process for initialize. You then go to load content, which is where you pull everything off the hard drive and get everything into memory that you need, all of that other type of stuff. You then go into the game loop proper, where it calls update, where you update everything about the world. Everything is done in update. Update is millions of lines long, right? And in theory, it actually is. It's just we have ways of making it not look that way. But you do everything in update. And when you're done with update, you call draw. And draw takes the state of the world at the end of update, reflects all the objects to reflect that, draws it out to the screen. Then you go back to update, do it all again, and it loops around until one of three things happen. One, the player closes the game. Two, the game is over, so it quits itself. Or the most likely one in our beginning circumstances, the game crashes. Let's admit it, that's always an option. Failure is always an option. But if you do successfully close out of the project, then you normally go to what's known as unload content. Most people don't actually do things like clear the buffers out of the video card and clear the buffers out of audio memory and stuff like that, because they just tell the video card I'm done and let the memory get overwritten. But unload content can also be done things like closing your network connections and things like that. But that's your kind of formal get everything else off and then the program terminates. Again, this is one of the most simple ones. I have seen ones for like pieces of the engine for, I was watching a talk on the engine for Halo, and their game loop has something like 37 steps in it. It's this huge, complicated thing that deals with everything all at once. And, you know, this thing can grow much, much bigger. But at base level, this is everything that's going on. You know, and fun side fact, how I made the point about how everything, you know, in the world kind of does this. WPF ran this exact same game loop behind the screens, behind the scenes. If you remember from WPF days, if you've ever played around with it, you could do anything you wanted until you hit, what was the name of that thread? There was a certain thread that then had to have solo access to everything, and then you went back on to other stuff. I think it was the composition thread. And it was the only thing that could natively touch the screen. That's because in our loop, that's the composition thread was where the draw was, and everything else was an update. And just like with the game loop, I have the book back there to prove it. If you want me to find it real quick, you could write shaders and pixel shaders and inject them into the WPF pipeline, because it was just running a game loop in the background. You could just give it additional steps to do during draw. Now, of course, I joked that if this is the way games really run, and by the way, this is the way games really run. Just about every game runs like this, every real-time game. How do you keep that update function from being millions and millions and millions of lines long? And that's where your components come in, and your game components and things like that. And that's where you break things up into smaller chunks that can be done on the side or can be called just like you would break up any other line of business application, right? You don't want your entire program to be in the main of the program class. The first thing you do is you instantiate a few things and you call out, and then this class will do other things, and all the stuff comes together and everything's magic. Same thing happens with game devs. And it most funnily comes down to a game component, right? What is a game component? It, just like a component is for something else, it's an independent, reusable piece of code. But when you think about it in games, think about it like there is not somebody writing for Super Mario Brothers a independent Goomba for every Goomba that happens. There's a piece of code that defines a Goomba, and when they need one, they drop a Goomba into the game, and then they handle that component until that Goomba goes out of the world, and they get rid of it. Same thing with game components. So then if you're running your game loop, you can say, I have a game loop, I have a component for my player character, and I have a component for these enemies, and I have a component for this, that, and the other. And then the feel of your game is really, what's the order I tell the update function, the actual engine of the game, to process these inputs, right? To process these components. When I start looking for collision detection, let's say I'm doing a shooter, do I check the bullets coming from the player before I check the bullets coming from the opponent? Do I clean up the bullets from the opponents when an opponent dies, or do I keep those bullets on screen? All sorts of strange things like this. All of that depends on the order you play around with these components. So your update really becomes with juggling how you're playing with the components at the time, and then letting all the code and the hard work be done in all the components. Does that make sense to everybody? Anybody have any questions about that kind of aspect of it? It was a subtle trick. I wanted an excuse to take a sip of my water. No, cool. We're good. All right. So now you got to worry about the separations of concerns, right? So how do you know what does what and what should go where? The way I like to put it is that components should really only ever worry about themselves. Inside, typically speaking, a component will have a mini game loop inside of it. And it's not really a game loop because it's not going to be looping itself. It can be done with threads where you can have a component running on a thread and then you just pull information out of it when you want to, but that's not very common. But think about, you tell the component, hey, it's your time to update what you want to do. And all it does is it goes, okay, based on the information I have in the game world, I want to walk this way, or I want to perform this action, or do whatever its AI tells it to do. And it says, this is what I'm doing. I don't care about anything. This is my decision. And then later the world kind of comes in after everything's been updated, and the world can go, well, you can't do that. I need to slightly move you back in bounds here. Or it kind of course corrects for the few things. That's one of the reasons why you get weird conditions where like somebody's running into a wall. We've seen the NPC running into the wall because it's trying to get away from everything. Its game component is just saying, put as much distance between you and the person firing as possible. There happens to be a wall there, but it doesn't care. It's going to try to run through that wall because that is the furthest distance away from the thing shooting at it. That's where you get things like that coming from. So how should you really put these things together? The way I like to say it is that when you first start update, the world needs to update the world. So the world needs to go, this much time is elapsed between frames. You will always get a real-time counter saying, between the last time update was called, this is how much time has passed. And then you can convert that into your game world time if you need to. Like if you're running on a compressed time frame, so, a 16th of a second, more like a 60th of a second, to you is like, we've been 3 minutes or something. Like if you need to do that type of, 3 minutes is kind of big. You get the idea. Like you can fudge the time frame from there. But the world updates the world. If that changes a day-night cycle, if it moves the position of the sun, kind of worldly type events, it kind of updates the world, the things it's in direct control of. The world is then going to go through, and in some order determined by the developer, it's going to tell every component, hey, this is the world now. What do you want to do? If it goes to the players, they get to look at the screen for that split second, so to speak, and it reads the inputs from the controller and it makes all the updates from there. If it goes to the AI of something like an enemy, the enemy goes, hey, based on what I see in the world, like is the person facing me or not? What do I want to do? And it makes up its mind. Other things that may be components all get to do their thing. They say, this is what I want to do. Everybody decides what they want to do. The world then goes back through real quick and ensures consistency with everything. So what do I mean by that? One, it makes sure something didn't go out of bounds and suddenly bring it back in. So the world can say, hey, you tried to move 30 pixels to the left. The screen was 20 pixels to the left. I'm just going to take off those last 10 pixels. You're now on the edge of the screen, right? The world can do that. The world can also, at that point in time, deal with the interactions between the objects. So this is where your collision detection comes in. And again, the order you do this stuff matters. So one of my original games I had written that I did was this little, very simplistic game. It was my first game, right? Everybody's got to start somewhere. It's called Kamikaze Comets. Asteroidy type things fall from the top of the screen. You had a little spaceship. You could move around. You could shoot the asteroids. If the asteroid hit you, you died. As time went on, they got slightly faster and they came more often. Right? Very simple thing. Got to start somewhere. One of the things I did, because I'm a nice dev, is that when I was doing the collision detection, I checked the bullets of the player hitting the asteroid before I went to see if the asteroid hit the player. The reason being is because if the player hit the button and spawned the bullet at the exact same time the asteroid hit the player, the bullet being checked first would then remove the bullet and the player, or the bullet and the asteroid, and then the asteroid wouldn't be there to kill the player. Whereas if I checked the asteroid collision first, the asteroid would blow up the player and then the bullet would fire past where the player used to be. It's those type of weird timing issues. And you're saying, hey, but that happened once every, 1/30th of a second. Nobody's that fast. People do get lucky, and pro game players will know when to time things by the frame of animation. It is a skill that can be learned. So don't say people don't do it. People do it all the time. So then after all of that, you then call draw because the state of the world is checkpointed for that instance in time. Draw draws out the state of the world, goes back up, repeat until everything happens. That's basically your game loop and how you design a game without getting into the minutia, which we're about to get into. So before we go forward, any questions on that general basic architecture type stuff? And please feel free to come off mute and actually ask questions.
Yeah, that's a loaded one, Chris. I don't even know where to go with that kind of stuff. I mean, I play plenty of games and I've seen all kinds of weird bugs. I mean, you can't not, right? Just stuff like being able to clip through the world, and if you find exactly the right spot, and you can just walk through walls, right?
Right. It's because if the edge of the box of the players just happens to get through because there's a small 1 pixel gap, it happens. And we're going to get into some of that stuff here when we get into the details. But like, again, that's your overall basic architecture. So, all right, let's talk about the world and everything the world needs to do. Because I think it's very conceptually easy once you explain game components and how they kind of chunk into the world to go, oh, it's the AI thing. If it's a bullet, it moves forward at this trajectory. It updates itself to this position in the world every point in time. If it's the player, we take these inputs, we tell it to move based on those inputs. AI with characters that aren't just boulders that fall at, in zero gravity. Why do you think my first game was like a little space shooter with asteroids? Because the asteroids had no AI. I spawned an asteroid, I gave it a vector when it started, and it just always moved along that vector. And sign up for the raffle giveaways. But that type of AI type, it's still just, hey, here's what I see in the world, here's how I'd respond to it. And they can get as complex as you need them to be. But the world itself, then it's like, okay, well, reconciling all these things. So what really is the world's responsibility, right? So the first thing the world should do is it's in charge of the clock. It's in charge of time, right? It keeps everything's running. Things that need to be based off of a time set. The world tells it when that happens. Things don't happen on their own. Sometimes-ish, but even then the world doesn't, because the world's in charge of the camera. right? Or if the world's in charge of the clock. So we can either be in my little silly game. There's a timer set that keeps saying how long it's been between frames. And I think it was set to at the beginning of the game, every 15 seconds a new asteroid would drop. And then every time an asteroid would drop, the timer got a little bit shorter and shorter. So the world would just report, hey, I have this timer. After this much time elapsed, I spawn a new asteroid, which was then just saying, here's a new game component in my list of game components, and it forgot about it. World, because of the clock, did that kind of spawning because it was a timer-based thing. If you're dealing with, hey, what time of day is it? Because your game is an RPG and has a day-night cycle. That's all based by the timing of the world. The world's in control of this global idea. That one should be relatively straightforward, right? But world also does physics, right? Because physics are the rules in which a world runs. Just like the real world runs on what we understand about physics, and have a degree in philosophy, so I could go way off the rails on that discussion. But just like physics, as we think of as a discipline in science, is the rules the world is based off of, the rules the world of your game is based on, and the physics that go on in that game are very much the world's responsibility. So the world, the player can say, I want to jump up all day long, but if there's nothing to jump up against, and the physics of the world are saying, no, you go down, the physics of the world wins. Right? Fortunately, you don't have to do all this stuff by yourself. There are plenty of physics engines out there. There's one you see a lot these days that deal with the physics of people. It's called ragdoll physics. You basically can put it on a player character and it makes all the limbs and everything behave. Like if they go limp, that's what makes all those limbs behave based on, like you're throwing a ragdoll, right? That's why it's called ragdoll physics. For overall world physics, there are things like the Havoc engine, which basically you give it a world and say, here's Havoc, and Havoc says, okay, how much gravity do you want? How much this do you want? How much that do you want? And then it just makes the physics work based on you changing all the constants. You would be surprised how many real world games don't use the correct physics model. You would be even more surprised to find out they typically have a higher level of gravity than you think, not a lower level of gravity than you think. And it's other tweaks that they do to get other things to happen. I think somebody calculated it. The gravity in Minecraft is something like close to 30 meters a second instead of 10 meters a second. But to compensate for that, the player character has like the strength of somebody to jump that is like 10 times the human limits or something like that. It's they do really weird things to balance everything. So don't think that anybody's just using Earth physics, because Earth physics is no fun. But yes, the world should be in charge of the rules of the world, and that is by definition what physics are. Big one, the world is in charge of the camera. I love this. If you've ever played Mario 64 in any of its incarnations, right? It also came out for the DS. It also recently just came out for the Nintendo Switch. Seminal game in 3D graphics. There's a part at the very beginning where Latku comes down holding a camera on a fishpole, just like you see, and all of a sudden comes behind Mario, and then Mario becomes the third person character, with the implication that Latku's behind him with a camera. But there's a mirror in the castle, and if you stand in front of the mirror, which is what this screenshot shows, then you can see Latku with the camera behind you because he's the cameraman. The reason they did that and made it that blatant, one, besides the fact it's funny and it's fun, right? And nobody's ever done anything like that before. But it gave them a reason why when the camera did really crazy things, that's why. Because Latku with his camera couldn't get up weirdly against the wall like you wanted him to. That was why, because it was actually a person in the world. the world's in control of the camera. The reason the world's in control of the camera is it has to decide what to draw. This comes more into draw physics than anything. So the player can say the camera is now positioned here, but the world one has to make sure that that's not inside a tree where all of a sudden you're not seeing anything. So it may have to move the camera to where that would be in a feasible spot. But then also when it gets to the draw phase, it needs to be able to take that camera and say, if I go outward, what am I actually seeing? And what can I get lazy on and not draw? It's called occlusion. It's called Z order, all sorts of tricks involved with this if you want to look it up. But the idea is here because of the mirror, you actually have to draw all of Mario. But normally most of his stuff in front of him where the camera can't see, you don't have to draw it because the person's not going to see it. So why waste the time rendering those polygons and triangles and everything on the graphics and the vertexes and all of that other stuff? Why bother with it? So that's kind of why the world's in charge of the camera, because that way you can't put it into a bad spot. And also it can then determine what actually needs to be drawn. And also weird things happen when there are multiple cameras. If you've ever played a 4-player game, typically what's happening is there is a world, and in the world there are multiple cameras, and you set up viewports on the screen, and the viewport shows what that specific camera shows. So it's all one world being rendered, and it's just showing different aspects. I kind of wish you'd have been able to do that in Mario 64, because I would love it if you could take one camera, look at the other one, but they never made it multiplayer. But that would have been really funny. I don't even think any of the mods have allowed that. There's a fun idea for somebody. Make a multiplayer Mario 64 and have a lat-Q following each person so one person can look at the other one. Good luck with that. The state of the world, right? It's in charge of what happens. So if we're talking about offsets, like in controllers, and the world checks the input, tells the player, here are the inputs for you, because it also could be checking inputs for multiplayer, right? And have to put things from other places. It could be checking inputs from the network and trying to reconcile what it thinks is going on. I think there's a fun slide about, no, it's not on here, so we'll get to it here. And if I'm wrong, we'll come back to it. But also, if a lot of these, like, do you want to fire a bullet every time the button's pressed, every time the button is down, or do you want to fire a bullet when it's pressed down? Right? And that's the difference of I hold down the button and I have infinite bullets just flying forward, or when I press down the button, I fire a bullet and I have to release and press down again. Well, if you want to do that type of thing, the game state needs to go, hey, during my last iteration, this button was up, now it's down. Do you want to do anything with the fact it's changed? So the game world kind of keeps track of all of those external states between the last frame and this frame, and just passes it on to the things that care. Ooh, I have notes in here, but man, you can't even see them because of how small the screen is. So my computer just flipped out. Awesome. And now, okay, we're back. Welcome to Tech Problems 101. But also dealing with status, we need to deal things like world timers. You know, everything comes back on itself. Is it daytime? Is it nighttime? Are we transitioning from day and night? Did we just move into a different zone? So we have to notify everybody, hey, we're no longer in the overworld. We're now in this town map. All the things like that. Those are the ideas of the state. It's how the world is sitting at the point in time when you get to make decisions on it. If you're playing a board game with your friends, the state of the world is, what does the board look like before I start my turn? Right? The board determines that. You just kind of roll the dice and or play your card and interact with it from there. But the world owns that state. Events. This is the one I was thinking of from a second ago. So, what kind of events can the world handle? We've mentioned one earlier. We have timing-based events, right? I want something to happen every 30 seconds. I want something to happen every 2 minutes, etc., etc. The world keeps track of this running timer of how much time has elapsed, when's the start time, trigger something when we hit this time, all those types of things. You get those beautiful timing-based events that we all know and love and think about. You get your world-based events. We've mentioned these before, day-night changes, moving between individual maps, moving between individual levels. You're at the end of level 1, you move to level 2. That's a world timer. That's a world change. That's that type of event. My personal favorite, position-based timers. If you've ever played Halo, you've seen position-based timers and you never even realized it. As you're walking through the world, all of a sudden you walk into a tunnel or out of a tunnel into a specific thing. And then Cortana starts talking to you. That's a position-based event. They wanted this thing to happen after you cross this threshold. Now that I've kind of shattered the illusion for games with you on that one, another thing that happens a lot with position-based timers or position-based events is spawning enemies. And I remember one very specific time. This was in the recent Tomb Raider remake, Tomb Raider Definitive Edition specifically, where I come around the corner and I come hopping down these few things, and all of a sudden 4 enemies spawn, and I get absolutely, too much in too small of an area. I can't handle them. Excuse me. And I remember, but I know how games work. And so when it spawned me back up at the top, I crept forward and put my toe over a magic line. And one came out. And I backed up and dealt with that one. And then I crept back forward again and crossed the second magic line. And then another one jumped out. And then I backed up and dealt with them. And if you kind of know they're happening, then you can really break things by changing, it's no longer I jump down into this arena and a bunch of things happen. It's I walk up to I walk in here and I know there are all these triggers all over the place, and I very carefully trigger them one at a time. On my stream on Sunday, we were playing Tunic, and you're supposed to walk into this big battle arena, and then the boss jumps up and you have to fight the boss. And I kind of figured out you had to be standing within a certain area of the front of the boss for him to wake up. So it was very convenient to just walk around him and collect a bunch of stuff beforehand and then come and decide to trigger him when I was ready. Because the trigger wasn't right when you walked in the arena. It was when you walked close to where the pile of rubble that turned into the boss started. Those are all position-based events, and they are everywhere. Again, if you're walking down a hallway and there are no enemies, and all of a sudden your AI companion starts talking to you, it's because you crossed a threshold that told it to start that audio cue. Always what's happening. I think, yes, that is the end of the actual content of the slides. Anybody have any questions or anything before we move on? I've got a couple other small things to talk about that I don't really have slides for. But any other questions about the world, some of these timers, events, all that other type of stuff? Everybody good there?
Yeah, I think you're just triggering a lot of gears to turn from it.
Yeah.
I don't know if I got a question at this point other than maybe just applying my day job brain to this is in the world of games. I mean, how much is, automated testing component of game design and game creation these days, or is it still just all manual testing?
So when it comes to all the pieces being put together, and the overall them interacting with each other, there is no good integration testing within games. Most of the people I've talked to have worked for game studios, things that they will tell you certain subsystems you can test together, but there is no test for how 7 AI enemies on a terrain plus a human are going to interact with each other. Just doesn't happen. So that is a lot of manual testing, a lot of going through and doing the weird things and seeing if you can capture what's going on so somebody can reverse engineer it. Having said that, unit testing a individual game component. When I give you this state, I expect this back. Very easy to do. Happens all the time. When I am simple interactions between two specific things. That could even be like the bullet and the enemy. That can be, does it stop when it hits a tree? And that, that could just be any force. Those type of smaller interactions with an integration test, very doable. But when you've got all of that stuff coming together, there's just no way to automate that type of testing because there are too many variables involved at that point in time to feasibly isolate a test. I give Bethesda Softworks a lot of shade. Just gonna say a different word there, but I caught myself. A lot of shade for how buggy their oh my god, these are the greatest game ever games are. Think of the Elder Scrolls series, Skyrim, Oblivion. Think of the Fallout series, Fallout 1, 2, 3, 4, New Vegas, all that stuff. But you really do have to keep in mind the number of game objects that are independent objects in the world that they're tracking. And there is no way to ever run a test on every possible combination of how they interact. Just cannot be done. You just try to get the game-breaking ones out of the way the best you can.
Yeah, thanks. Yeah, I mean, I think just with their character creation, right? You just get so many options. The combination is just in a character, let alone the world they're in. That I just think, the number of variables you have to even try to test, even if you can work the input out, is insane. So, thanks.
And I mean, and sometimes time makes a huge difference. And by that, I mean technology. One of my favorite games of all time, Dead Space. Just recently put out a new HD remake, the Dead Space remake. It is phenomenal if you like horror games, but that's beside the point. But the original version, there were cuts and loading between individual pieces. All the chapters were set by themselves. It was, nothing wrong with that. Again, the game was like 15 years old at this point. I think the original was 2008. So, it was amazing for what it was at the time. But with this new version that just came out, I've been noticing like I can do things in one part of the ship in chapter 2 and have certain weird configurations of things I left. And then when you eventually have to go back to that thing where I am now in chapter 9, all of those things are still tracked in exactly where they are. They didn't reset. The game engine is keeping track of the state of the entire ship over the course of the game and handling it. Because some of it's just thrown in the background going, yeah, this lives here now. We'll worry about it later. But I mean, now you've got to deal with, I have the interaction of every movable item on this ship, and I'm tracking exactly where it is through the entirety of a 10-hour playthrough. Give them some slack. That's all I'm saying.
Yep.
Some other fun anecdotes of ways to break games. If you're ever inside of an elevator or a cave or a trolley and it's an enclosed space, it's a loading screen. You can really test this if you know how to do it. Improve, especially when you're dealing with caves. Halo is notorious for using caves and hallways for loading screens. So you'll be walking down the screen, you'll get into the hallway and you'll start walking down it. And what you won't notice is as you're walking forward, it unloads all the textures behind you and dumps the previous area. And then it starts loading everything it needs for what's going forward. And then when it's finally got everything loaded it needs, the door will render as you're walking down the hallway. And then you can go through the door and everything's loaded. That's how they hit their loading screen. Is all of these quantum hallways that have variable length depending on how long it needs to do everything. And the fun way to do that is if you know where to find the point, and sometimes you got to play around a little bit, the point in the hallway when it decides to dump what's behind it and start loading what's forward, and you can find that point and go a little bit past it, and then wait like a half a second, and then turn around and go back over the line, the game will go, oh shoot, and suddenly try to reload everything from the old place that it just dumped out of memory. So all of a sudden you can walk through a door, through a hallway, take 4 or 5 steps forward, wait a second, turn around, and then it's a much longer walk back to that door because it has to reload everything it just unloaded. It's a real fun one to go look for. And then the other fun story is a lot of times I don't think you all realize networking's hard, right? It's hard before you're dealing with real time. Now you're dealing with games where if you've got a good ping of 20 milliseconds, that's 5 frames a second. That means if you're moving the game at 60 frames a second, that's a whole lot of guessing it has to do between frames. If you've ever played a network game and all of a sudden you start seeing characters moving, because some games just don't care and they'll just have the jumpiness because the real-time interaction doesn't matter. But if it does matter, they'll do all sorts of tricks to catch up with it. And it's hard to catch these in the wild. But there is one place you can go online to see where it happened, which doesn't happen anymore. But when they were first playing around with this real-time stuff, Bungie doing Halo, and I know I use Halo a lot as an example, but Bungie was really open with everything they did behind the scenes. That's why we have all the good dirt on it. They were like, we couldn't get network inputs fast enough, even on LAN play, because they were on LAN play to keep the game performance. So what they came up with is that it would kind of in the background guess what you were going to do next based on your last couple inputs and kind of do that. And then when it got an input that contradicted what it thought it was, instead of jumping the player, it would start to slowly over time correct it and move it back to that point until it met back up with reality. So you didn't get the huge jump. It would just sort of course correct until it merged back into reality. The problem with this was that the server had to know what was going on at all points in time amongst all players, because you're talking real world gunfights and everything. So occasionally between all the network lags and everything and it being able to get and reconcile all the inputs, somebody would not die who should have died. It happens, right? Based on the information at the time, you survive. And then suddenly it gets all the information. It's like, nope, definitely not. When the server discovered that happened, because it was in the past, at that point in time, it was too hard to figure out who actually should have gotten credit for it. But they knew you didn't survive. So the game would kill you. And so all of a sudden you would see people right out in the open with absolutely nothing going on, and then they would die. And it would say, so-and-so was killed by the Overlord. The Overlord was the AI inside of it that said, nope, now that we've actually figured out all the inputs and reconciled the world, you did not survive that. Be gone. So you can go on YouTube and there are videos. I think you can look for Halo 2 killed by Overlord of things where that happen, where there's this great big firefight and everybody dies and there's one guy running along and then all of a sudden at the end he just falls over and it says was killed by the Overlord. That was the networking code finally catching up with everything that happened and going, nope, sorry, we let that one slide. So again, networking's hard. You're trying to run things at at best case scenario, 30 frames a second. If you're getting 200 milliseconds or 20 milliseconds, you're not getting that same performance. So weird things have to happen. Let's go ahead and get to this one real quick. Thank y'all very much for sitting here and listening to me ramble for about an hour. There's all my social stuff and whatnot. I am extremely unactive on Twitter these days with everything that's going on. So below that is also same name. My go back. My Mastodon. Also email if you want to get a hold of me. All my code for everything I have is on GitHub, including a couple games which are up there on GitHub. And then I do live streams on Twitch, play games on the weekends. Here soon, we're going to start back up the coding on the weekdays due to some schedule conflicts. I had to stop for a while, but it's coming back here soon. And then the information for my conference. What questions and everything you got for me?
Hi everyone. Okay, I'll share a video. Sorry, I'm like folding clothes. I have my twins with me. We were actually trying to learn how to make some games because they're really interested in that. But I know that you had mentioned Scratch earlier. My son basically like lives on Scratch Junior. How would we like go about if we wanted to kind of start trying to like, would we maybe YouTube videos help out with like tutorials on how to make things online or with the Scratch app? Website.
I do know Scratch is highly documented and used and talked about. So you can definitely find a lot of stuff on YouTube. And I think they even have, it's not really a marketplace, but they give you a way, and I haven't touched Scratch in a while. My kids have gotten a little bit older to now they're playing around with creation tools and Roblox. So I'm in a whole nother world. But there used to be a way where after you could create something, if you wanted to share it with your friends or share it with the community, they would give you a code, which basically reverse engineered the code to where you could copy and paste it and it would recreate it on the other side. So there are ways to do that. I don't know if there is a tool that will just like make it a standalone. But I think anything you make in the apps, you can then, with the code that I know used to exist, bring it to the web page. And I'm pretty sure the web page will then can give the Scratch web page, and it may be a member feature. I don't know. Again, I haven't played around Scratch in a while. It will actually, give you a cleaned up link to where you could share the URL with your friends, and it would bring up your project and they could play it and you could share it that way. So I know all those options are out there. It's just, it's been a while since I've played with it because I've kind of been in a different world lately.
I completely understand. We tried to do Roblox. He was trying to build like a Plants vs. Zombies game, and it got very complicated very fast, especially as a beginner. So I said maybe let's try with Scratch. But thank you, I appreciate it.
Right, because Roblox is basically using Lua as the scripting language, so it's a complete engine, kind of like Unity and all that is, with the same asset stores and everything like that. But its scripting language, instead of being something nice like C# is Lua, which is basically the scripting version of low-level C. So yeah, it can be very difficult to get in with at first if you don't have decent programming fundamentals to begin with. They claim it's easy and a kid can do it, but I mean, even I looked at it the first time and I was like, yeah, I've got a master's degree in comp sci and that ain't easy, kid. So any other questions? If somebody's interested in working in the industry and has C++ or C# knowledge, what path would you recommend? A, working on your own project in spare time to build some prototypes, or B, apply to game job devs outright, or both? Any other hints? Okay. One, if you make an indie game and publish it, it could get something out the door. That is the biggest thing you can ever do to get into the industry, right? They want to see people who can complete and ship things. And it's also a great way to learn. However, if you want to get into the game industry from line of business without going that direct route, there are plenty of And like, especially if you've already got C# knowledge, believe it or not, a lot of game devs are using C#. You can get in through their tools division, which is a lot of C# programs that are doing things on the side and helpers and stuff that may not actively be involved in the game, but then through the tools, you can then start to learn and then get involved more in the other parts and get into the actual game part. So that is definitely a way you can go. I've got a friend who out of college had no game and experience. He works for Naughty Dog because he came in through tools and networking stuff, and then eventually got over into actually writing games. The thing I will warn you about this, if you go to work for a AAA studio, even though the industry is getting better about it, it's nowhere near as bad as it was. Expect long hours and little pay. And the reason being is because they don't have to give starting people good pay, because there are 500 people who want that job. So just know that going into it. Definitely giving that, if you can on your own prove that you can write your own game, you're more likely to get in at a level to where you're not getting that, hey, I got 500 options. Why am I taking you? I can pay you almost nothing. And then you also hear of a lot of people getting into game dev through QA. They're always looking for QA people. And if the QA person is good and then is contributing good things, sometimes they'll get moved from external QA contractor to internal QA. And then from there can get into programming. There's a couple other ways. Is there a way that people in this lecture can connect? Also, will the recording be available? I know it's being recorded. I know he says he's going to put it on YouTube. I am not the person to ask that to. Merrick was the person I said.
Yes. So recording would definitely be available. It'll be on our YouTube channel, and I will post the link on the meetup page itself. And as far as connecting, if you feel free to post a comment on our meetup page. If you're looking to connect on a certain on any topic, I'm sure people will respond to that.
There you go. Yeah, and somebody posted in chat about a formal program if you want to go through it. I have not vetted it, but they said that it was really good, so I will take their word for it.
Yeah, someone asked if with a C# background, C++ background, that program is excellent. So if you're looking for something formal, I know you can do it fully remote. There are some really challenging courses in there, and take all the classes from Ed Keenan. He was the Midway Games chief. So.
Anything else? I know we're bumping up on time now, but I mean, we're all sitting at home folding laundry. What does it matter? I make that joke, CC, because I don't know if you were in earlier when I said it, but I think ma'am was talking about, sorry, about the kids in the background. It's like, okay, as I was coming in here to get ready, my son just about threw in some laundry to turn on, and the washing machine's on the other side of this wall. So we'd have heard the washing machine the entire talk if I didn't barely catch him in time.
Well, glad you did. Right.